To introduce myself, my name is Martin Fechner and I'm working at the Digital Humanities Department at our institution. That's the Berlin-Brandenburg Academy of Sciences and Humanities. Our institution is going to make ground research in the field of humanities. Our department, Digital Humanities, are helping all the research projects with their research and bringing it to the digital. And this lecture deals with a software project which was developed in the context of scholarly editions. To say what are scholarly editions? Scholarly editions make historical sources, such as letters, diaries, etc., from archives accessible to researchers. For this purpose, the sources are transcribed and commented by the researchers. And at our institution, the Berlin-Brandenburg Academy of Sciences and Humanities, there are a lot of such editions, like on philosophers like Leibniz and Kant, and on other famous personalities such as Karl Marx or Alexander von Humboldt, who has written a lot of letters and papers which are not published yet. So our software project, which we build now, establishes a digital workflow for the scholarly editions, and this is known as digital scholarly editions. Yeah. Digital scholarly editions follow a genuine digital paradigm. That means that digital thought not only as a tool, we don't only build a tool, but as an independent method. It's a thinking of how to establish the editions. And digital scholarly editions are usually in our field are encoded in the XML format and according to the guidelines of the text encoding initiative, which is a standard. And the aim for our project or at our institution is to make the edited historical sources available for subsequent use and to be able to link them with further information and to link them to other databases. So that's to bringing it to the digital, not only the books who are in the library and you can read, but you have all the stuff and other databases you can use. A further goal that is from our perspective more from the technical one is the single source principle. That means to be able to generate everything from one data source, in this case the XML documents. And both web publications and print publications are relevant presentation formats for scholarly editions now. So our initial situation in 2011 and 12 was as follows. It was clear that we needed a new workflow for many projects in the house. The previous one no longer met the requirements for digital scholarly editions. Before that, the main focus was on scholarly editions, printed ones, but we had to produce digital websites and more. So the edition project Schleiermacher in Berlin, I have to say Friedrich Schleiermacher was a famous Berlin theologian of the 19th century, and this edition project offered at that time, 2011, the opportunity to implement a new workflow. At that time, however, there was no software that would have met the requirements of the edition projects at our institution for the creation and publication of digital scholarly editions. Furthermore, we had only few resources, like it's usual in the science or in humanities. We had only few resources that we could use to create a software solution. Consequently, the decision was made not to try a completely new development, like we had heard in the video talk before, but to use our resources carefully and to use existing software and further develop it where necessary. In our case, there were the XML database exist DB, the XML editing tool, Oxygen XML author, and the typesetting engine Contact. And this approach led to success. We were able to create a software solution that we now call ediarum. And this solution still supports the workflow of the project today, relies on sustainable data format, the XML format, and makes all desired forms of publication on the web and in print possible. So this successful digitization project was characterized by the following key points. We used a bottom-up approach. That means we had a concrete development for one existing project, that was the Schleiermacher Scholarly Edition, and we had to provide more resources for development than was usual for previous projects. For this digitization project, we had about 2 developers with one full-time equivalent over a period of about half a year to a full year. And for comparison, previously we planned only with periods of a few weeks or months for smaller projects. We had a close communication with the research project or the scholarly edition project. And we made use of existing stable software with good support. That was the key. We don't needed to program everything ourselves. And we developed adaptations and extensions of this different software solutions by our own solutions. And as a result of this pilot project, there was a very positive feedback. We took this feedback as an opportunity to immediately transfer our development and software concept to another research project. That was the project Commentaria in Aristotelem Graeca et Byzantina. It's a manuscript research project. There we started from scratch and put together a software package similar to the one for the first pilot project. This project was also subject to the key points which I mentioned and was very successful. We moved one step closer to our goal, the digitization of the scientific, of the scholarly editions at our institution. But nevertheless, with the success, grew the desire to use ediarum, how we called it then, our software solution, in many other projects. But we were only able to realize 1 or 2 new projects at the same pace. We had to be, to be more productive. And at the same time, we discovered that we often reused the code already developed for one project in another project. And this copy and paste approach accelerated the implementation, but also led to existing errors being duplicated. That means we had, if we found an error in one project, we had to remove that error in all our projects, and that's a work we don't want to. So the operation of several software solutions for individual projects, including further development and bug fixing, as well as the desire to be able to implement new projects easily, led to the consideration of restructuring our development process. As a result, we no longer programmed for each project alone. That's a bottom-up approach I've talked about. But we switched ediarum to a generic, easily adaptable program core. So the concept of ediarum today includes common core components which are used in all projects. There are new features, the new features are implemented and bug fixes are made in the core components from which all projects profit at the same time. Furthermore, there are project-specific extensions. That means for each project there's its own program code that supports the special requirements, because the projects we have are very different and heterogeneous, so we have to have a specific code for each project also. The basis for this approach was standardization of the data model, which is used by the project. At this point, one common data model for all projects, even different ones, cannot be emphasized clearly enough. This is because all ediarum modules built on the data model in one way or another. It's the basis of all software. And a generic development of ediarum requires a standardized data model. So 2015, the standardization of the data model took place first for a certain project type, of which we have many projects that are modern German editions. There are different editions too, but we have a lot of the scholarly editions for modern German. And based on this, several ediarum modules were developed, which take over individual tasks within a digital scholarly editions. There we have ediarum DB that provides possibilities for project, user, and data management within the XML database. There are ediarum base edit that extends the XML editor with the necessary features to provide the researchers with a meaningful data input interface, because the researchers don't have to learn the technical stuff behind it. They have to do their research and to read the manuscripts and to transcribe and comment them. So they don't have the time to learn all the technical stuff. We have ediarum PDF that contains the program code to generate a PDF from the XML files via the typesetting engine, which follows the layout of common print editions, of scholarly editions. We don't print that PDF to a book. There are the publishers who does that, but the researchers wanted to have a PDF to read it, their editions, and to correct it. And then we have, of course, ediarum Web that contains a program library with which a digital presentation for digital scholarly editions can be created. without much effort. Here I have our structure visualized with different layers, and the different modules represent the different layers of a digital edition. You see at the bottom line the data model, and then the layers above are the data itself, the management and the publishing on presentation components, and we have in color are the core components, and then we have here in gray project specific components. And our development workflow today is as follows. If there is a new feature request from one project, we check to what extent this requirement also exists in other projects. If it is only a project-specific need, the implementation takes place in the project-specific extension of ediarum. But if there are similar requirements in other projects, the generic development process starts. That means for the development specification, all similar requirements of the different projects are brought together, and sometimes during the implementation the possibility must be provided that the feature can be adapted project specifically. So the usually done this by integrating variables in the code that then are defined in the project-specific extension. The generic development approach has enabled us to strengthen and continuously develop the core components, which is good for all projects. And furthermore, it's relatively easy for us now to set up new projects and make them ready for work. Finally, the project-specific components, as in the bottom-up approach, make it possible to implement specific requirements for individual projects. So, I come to the conclusion and summarize the advantages and disadvantages, as well as the path of a change from a bottom-up to a generic programming. First, let us start with a path towards a move from bottom-up to generic programming. First, experience will be gained in individual pilot projects, and we saw that more resources than usual must be made available for these pilot projects. So they have to be well developed, and you don't have to short the resources down. And then 3 conditions must be met before a changeover to generic programming can take place. First, the pilot projects were successful. Yes, that's clear. Then further projects are to be implemented. That's clear even. And a common core, such as a common data model or repeating program code, can be identified. So the next step in the changeover is the development of a core component without project-specific requirements. With the new work you have to be, which has to be done. And the implementation of the generic components for concrete projects is the next step. And here on the last point is, and that's very important, you don't have to forget the migration of the pilot projects to the generic components, because you have developed a new structure then, and the pilot projects are still individual projects. You have to migrate them. And once all this has been done, the further development and maintenance of the software can take place in the generic programming, as I has described. This approach requires addressing the following challenges. We heard in the video talk before, in science there's only project financing. That means generic development, as I have described here, must be project independent and requires additional funds of its own, because you can't fund it out of the projects. The next one is the generic development and the project-specific development compete with each other. That means that the completion of important milestones for the projects, and you have these milestones for evaluations or publication dates, etc., and that leads to a postponement of necessary generic development. And that hurts a lot, because you see the importance of the generic development, and a lot of projects want a special feature, but you have to reach a milestone for one project and you can't do the other development. The next one is when switching from individual projects to a generic approach, similar but not identical program code must be brought together, and this can be difficult and as well can mean additional work. Migrating the pilot projects, as I have said, and other existing projects to the new approach can be very time consuming. This improves the sustainability of the project, which is good, but there are no visible new features for the project, which is bad for the evaluation and the outcome of that specific project. But nevertheless, this approach, which I have described, has proved successful for us, because we see the following advantages. The first prototype is ready for use more quickly in the bottom-up process, because at first only the requirements of one project have to be considered. You don't have to think about all the stuff, you can focus on one project. And the goals of your software are supported by the strong focus on the projects. You don't lose the contact to the project. You communicate with the projects very, very close, and you know what they want and what they need. And the software is strongly oriented to the concrete needs of the users. The software is not designed too theoretically. That means the danger of developing without the real needs is much lower than in a generically planned software, if you only have the general view. So also not too little, not too much is developed. The necessary features are implemented, but not no unnecessary ones. The use of generic core components and project-specific extensions will achieve a reasonable balance between desired standardization and required project-specific adaptations. And the last point is the generic core components, and that's very important, significantly simplify the maintenance of many projects. And we have a lot of projects we have to maintain at the same time, and we don't want to have different software code beneath it. So yeah, if you're interested in our software solution, here are some further information. And by that, I thank you for your attention.